When a massive electrical discharge tears through the sky, the effect is obvious. A thunderstorm accumulates huge amounts of static charge, and lightning is the violently visible result of that charge finding a path to the ground. But take away the clouds, the air, and the earth. Imagine a pure theoretical void. If we place a single isolated electrical point charge into this perfectly empty space, absolutely nothing happens. The physics only seems to kick in when we introduce a second point charge nearby. Instantly, an invisible connection bridges the gap. Depending on their polarities, they either pull together or push apart. This creates a logical problem. If we remove that second charge, the physical force of attraction or repulsion vanishes. Does that mean the space around our first charge goes back to being completely empty? The idea of forces jumping instantly across a perfect void troubled the 19th century scientists mapping these rules. It felt like magic. There had to be a physical mechanism communicating that push or pull. The original charge actively alters the surrounding environment, essentially rewriting the properties of the space itself to create a physical bridge. Let's focus solely on that original isolated charge. We'll call this the source charge. Even alone in the universe, it is doing work. We can visualize this work by mapping its electrical environment in three-dimensional space. If our source charge is positive, it generates a field of vectors radiating directly outward in every direction. Notice how these lines behave. The closer you are to the source charge, the longer and denser the vectors. As you move away, the field strength drops off sharply, fading as the distance increases. This formula is the mathematical definition of that electric field. The strength of the field, E, is entirely determined by two things: the magnitude of our source charge, Q, and the square of the distance from it, R. The geometry is perfectly symmetrical. If we flip the source charge to a negative polarity, the entire grid reverses, pointing radially inward. The source charge acts as the sole creator here. It dictates the exact conditions of this electrical environment entirely on its own, regardless of whether any other object ever enters it. Now, let's see what happens when an intruder does enter. We'll drop a second charge into this established space. This is our test charge. We define the test charge as being negligibly small for a specific reason. We don't want its own electrical presence to push against the source charge and ruin our carefully mapped environment. As soon as the test charge arrives, it experiences a physical push or pull. It reacts strictly to the local field at the exact coordinates where it sits. We calculate that physical force by taking the value of our little test charge, Q, and multiplying it by the value of the surrounding electric field, E, at that specific location. If we reduce the value of our test charge down to almost zero, the physical force acting on it also shrinks to zero. But the grid itself, the electric field, doesn't flinch. Physical force requires a victim. It takes two charges to interact, but the electric field belongs entirely to its creator. It exists as a permanent fixture at every point in space. At this point, it is fair to ask if the field is just a convenient accounting system physicists invented to calculate forces without going crazy. Is it a mathematical trick? To find out, we put the source charge in motion. Imagine our creator charge suddenly and violently shifting its position in the void. If we check on a distant test charge the very instant the source moves, its force vector hasn't updated yet. It is still reacting to where the source charge used to be. This time delay is a hard physical limit. No signal, no interaction, and no information can travel faster than the speed of light. When the source moves, it creates a disturbance. That disturbance ripples outward at the speed of light, carrying the updated location across the void until it finally crashes into our test charge. Electric fields occupy space, evolve according to their own dynamics, and transport actual energy as tangible physical entities.